What's going on, guys? In this video we are going to see how to solve this transistor. First I'm going to apply KVL in the first loop, KVL 1, and here the current is going from negative to positive, so this is going to be plus 2 minus 100k times I1, 100k times I1 minus 200k times, there are two currents. I1 is along the path, so I put I1 here, and I2 is opposite direction, so minus I2. The whole thing is equal to 0. Now if we simplify this one, here we have 200k I1 minus 100k I1. Totally we are going to get negative 300k I1 and negative 200k negative I2. That's going to be positive 200k I2. Positive 200k I2, that's equal to negative 2. Okay, that's KVL 1, and I'm going to apply KVL for the second loop. KVL for the second loop. If I apply KVL for the second loop, this is going to be 200k I2 minus I1, 2 minus I1 minus this base emitter voltage, that's 0.7. 0.7 is equal to 0. So this is going to be 200k I1. This is minus because it's going this direction. So minus 200k I2 minus I1, minus plus. So 200k I1 right here, and minus 200k I2. That's equal to 0.7. Now what we have to do is we just have to add, let's say this equation number 1, let's say this equation number 2. If we add these two together, 1 plus 2, this is going to become minus 300k I1 plus 200k I2 is equal to negative 2. And this is going to be 200k I1 minus 200k I2, that's equal to 0.7. And when we add these two together, these two are going to cancel. This one and this one cancels, and here we are going to get negative 100k I1 is equal to negative 2 plus 0.7, that's going to be negative 1.3. So I1 is I2 cancel, so I1, if we solve for I1, we are going to end up with 13 microampere. Okay, now we have solved for I1. Now the next thing is we have to solve for I2. To solve for I2, we can plug it in one of these equations. Let's plug it in this equation. Okay, if I plug it in this equation, this is going to be negative 300k I1, that is 13 microampere, plus 200k I2, that is equal to negative 2. Now from this one, if we simplify this one, this is going to be I2 is equal to 9.5 microampere. Okay, we have solved for I1 and we have solved for I2, and then to solve for I3, okay, let's put a path along like this. I3, to solve for I3, I apply KVL in the third loop. KVL 3, here we have VO, let's call this one V sigma minus 1000 times I3, 1000 times I3, and minus positive to negative, so minus 16 voltage, that's equal to 0. And also we have a equation that is I3 is equal to beta times negative I base. Negative I base, beta is given 150 times I base. I base is negative 9.5 milliampere, negative 9.5 actually microampere. And if we solve for this one, this is going to be 1.425 milliampere. And when we simplify this one, this is going to become negative 1.425 milliampere. Now if we solve for V sigma, this is going to be V sigma is equal to 16 voltage plus 1000 times I3. So 16 voltage plus 1000 times negative 1.425 milliampere. And when we simplify this one, this is going to be 16 voltage minus 1.425 voltage. That's equivalent to 14.575 voltage. And that's the V sigma. And that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you're trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.